Hey guys, it's Miss Simmons. Today what we're going to talk about are input-output tables. Yesterday we did a warm-up where you guys filled in an input-output table using an equation that you were given. We also talked about dependent and independent variables. If you remember, I asked you what you thought input meant and what output meant, and we said that input is your which variable. Right, it's the independent variable, and your output is your dependent variable. We also said that input was represented by your x values, while output was represented by your y values. So if you look on your note sheet, you have these same questions. So what you want to do is go ahead and fill in what input means and what output means. Next up, we have what is input-output. You have a little chart here that has your x values and has your y values. And what we want to do is figure out what the relationship is between your x and y values. Now we know that the input is when you are substituting in a value for x. So we want to say input is substituting. That's not a very good color, is it? Let's change that. Input is when you are substituting in your values for x. Don't know why it changed that color there. Sorry, everybody. And your output is basically like your answer. Okay, so you've got this table, and I think you have arrows coming off that tells you that x is your input and y is your output. And we want to figure out what the relationship is between x and y. So we want to be able to write a relationship or an equation that says y is equal to something. Remember, that's our pattern. Y is always equal to something with an x. So right now what it looks like is as we plug in an x, how did I get to y? If you said add 1, then you're correct. When I plug in an x, I need to add 1 to it to get what my y value is. So you have to double check that and make sure that it works for each one of your x input values. So if I plugged in a 2, if I'm saying that my equation is x plus 1, if I plug in a 2 where that x is, that should give me a 3. So if I substitute in 2 here, 2 plus 1, well, it does give me 3, so that's true. Let's check the rest of our values. 3 plus 1 does give me 4, so that is true. And then 7 is my last one. Notice that my table does not go in order. You can substitute in values that don't go in order. You just have to make sure that when you do that, you're still following this rule. So I'm going to substitute in my 7. 7 plus 1 does give me 8, so that is true. The good thing about an input-output table is that you can graph your results on the coordinate plane. Remember, we talked about why we use x and y as our variables most often, and it is because they correlate to the coordinate plane. So what I want to do is come over here, and I can see that my x-axis is labeled and my y-axis is labeled. So for my first ordered pair, I'm going to plot 1, 2. So what I want to do is come over here on my x-axis and find the 1, and then I see that the y-coordinate that goes with that is 2. So I want to place a dot right there. Let's make it a little bit bigger. Hard to see. Okay, so for my next ordered pair, that's right here. I've got 2, 3. So I want to come over to 2 on my x-axis and go up to 3 on the y-axis. Same thing, my next ordered pair is 3, 4. So I want to come to 3 on the x-axis and up to 4 on the y-axis. My final ordered pair is 7, 8. So I want to come over here to 7 and make sure that I go all the way up to 8. The great thing about this is if you notice that your dots are not going in a line, something is wrong. You want this to be linear, which means in a line. So what we're going to do next is we are going to practice by plugging in values for these equations. So what I've done is I have picked up where you guys are in your notes. You should see an area that looks like this on them. And we have all of our inputs filled in already right here. So you can see that my equation is going to be y equals 2x. And what does it mean when you just have a number or a coefficient attached to a variable? What's that operation? If you said multiplication, then you're right. So what I want to do is I want to follow this rule by substituting in my values for x. So when I plug in an x for this particular spot, I know that my first x is 3. So I want to come here and I want to say, okay, 2 times x, which right now my x is 3. What is 2 times 3? Well, that would give me 6. So I want to keep doing that. I want to keep plugging in my values. Right now I've got a 4, so I want to substitute in 4 for x. So 2 times 4 is going to give me 8. Again, substitute in 5 for 2, or excuse me, 5 for x. So you've got 2 times x, which is 5, which should give me 10. Your final value is 6. So 2 times 6 will give me 12. And you can see that I've kind of followed a pattern. Okay, so now that we filled in our chart, what we want to do is come over here to our coordinate plane, and we want to actually plot those x and y points. So remember, we want an ordered pair with an x and a y. So I need to come down here to my x-axis and plot these. So I need to come over to 3 and go all the way up to 6. Same deal with my next one. My next x value is a 4 and my y value is 8. So on the y-axis, or I mean the x-axis, I need to come over to 4, go all the way up to 8. Next one is a 5, so on my x-axis I find 5. Then I need to travel all the way up to 10. Now you may have noticed that 12 is not part of your y, so we kind of have to make an educated guess as to where 12 would be on the y-axis. So I find my 6 for my x value and go up to about where I think 12 would be, and I'm going to guess it's about here. That looks about right. So notice we have that straight line again, which means it is a linear equation. It makes a line. So we know that we have done this correctly. Moving on to your next equation, it says y equals 1/2 times x. So don't freak out when you've got those fractions. Remember, we know how to do this. We can multiply by a fraction. So we want to come down here into our table of values, and basically when you multiply by half, it's the same thing as dividing by 2. So I can do two things here. I can treat this like a fraction already, and I can say 1/2, and then I can actually multiply it by these values. So I could show my work over here, 1/2 multiplied by 2. And we know that to multiply fractions, you need 2 fractions. So I've got 2 over 1. So when I multiply those values together, what's going to happen is 1 times 2 is 2. And then 2 times 1 is also 2. Now, 2 over 2 is the same thing as 2 divided by 2, which we know is equal to 1 whole. So in my table of values down here under my 2, I know that y is equal to 1 whole. Now, like I said before, when you multiply by 1/2 or 1 over 2, that's the same thing as just dividing your x value by 2. 2 divided by 2 is 1. So if we want to follow that same mind frame, we can say to ourselves, okay, I know I need to take half of my x value. So what is half of 4? Well, half of 4 would be 2. Do the same thing. I'm still following that rule that's written in the equation. 6 is my next x value, so half of 6 would give me 3. And then finally, half of 8 would give me 4. So my next thing is to go down here and actually plot those points, and you guys should be getting pretty good at this by now. So again, we need to look at our x and y pairs, or our ordered pair, and that means that my first ordered pair is 2, 1. So I need to find 2 on the x-axis and go up to 1. Probably need to make that dot a little bigger, huh? Okay, next ordered pair is 4, 2. So I find 4 on my x-axis and go up to 2 on my y-axis. Okay, next ordered pair would be 6, 3. So I find 6, go up to 3. And last, I've got 8, 4. So I need to find 8 and go up to 4. Now, as you can see, this line is not as steep as our others, and that's because we have a fraction that we're multiplying by. We know that 2, which I had in my first problem here, is much larger than a half, so my line is going to be a lot steeper or increase quicker than this one would. So if you turn to the back of your paper, you should see something like this. Now, it says write an equation for the relationship shown in the table, then find the missing values in the table. So basically what we want to do is we want to write an equation that says y equals something, because our equations always start with y equals. So I know that y equals, and then my job is to find the pattern. How am I getting from this x to the y? What's happening between x and y to make it increase from 20 to 23? What about from 40 to 43? And then the last one that's actually filled in is 80 to 83. So the pattern that I noticed is that we were adding 3 to the x each time. So we've got to make sure that that works for every single one of these. So if I add 3 to the x, that should give me my y value. And if that's true for each one of these, then I've found my pattern. So what I want to do is come down here and actually write that pattern, and what I said was we have to write what's happening to x. So I know that y is going to equal x, and then we said that the pattern was plus 3. So my equation is y equals x plus 3. So now I need to come back into my table here and actually fill in this value. If the pattern is y equals x plus 3, I need to plug in that 60 that I've been given for the x. So if I plug in 60, or substitute 60 in for x, and I add 3, that should give me 63, which is the correct answer. Moving on to number 2. Look at your pattern. Try to figure out what's happening to your x to make your y. So the first thing that I think of is, well, maybe it's plus 15, because to get from 3 to 18 I would add 15. But I have to make sure that that rule works for each one of these. So if I added 15 to 4, would that give me 24? Is that true? No, that's not true, so that can't be the pattern. So maybe think of something else. What else would work? How could I get from 3 to 18? And then from 4 to 24, and then from 5 to 30. So what I think is happening is I think I'm multiplying by 6 each time. So let's make sure that works. 3 times 6, yes, that is 18. 4 times 6, well, that's 24. And then 5 times 6 would give me 30. So then to find my last value, I would need to follow that pattern of 6 times 6. But I need to write a rule before I fill in this chart. So we always start with y equals. And then we want to write what's happening to the x. So what's happening to x is it's being multiplied by 6. But to write that mathematically, remember we don't need symbols to denote multiplication or to show that we are multiplying. So we want to put 6 times x. So let's follow that pattern here. We said it was times 6. So 6 times 6 would give me 36. Okay. So now that you understand how to write the equation, really you just want to define that relationship between the x and y. Tell yourself, okay, well, what's happening to the x to make the y? And then write it using y equals, and then tell us that rule. It's x plus 3 in this chart, and here it's 6 times the x value. So moving forward, here you're going to want to fill in your input-output table to make the equation work. So it tells you the equation in these two, and I'm going to let you pause the video here to fill it in, and then when you have filled it in, restart the video so that you can see if you got the correct answer. Okay, welcome back. So, looking at the chart, see if you filled in your input-output table correctly. If you did, kudos to you, you're doing great. So let's move on to the last portion of our notes here, and this uses a little bit more of a complicated equation. It's not really that hard. Remember, it's just like substitution, so we just want to follow the rule that has been set forth. So for number 5, it says y is equal to 2 times your x value, and then you're going to add 1 to that. So in my chart, remember I have a 1 here, so I want to plug in or substitute in that 1 for x. So 2 times 1 would give me 2. And then I want to add 1. So 2 plus 1 gives me a value of 3. Okay? So again, it's just like substitution. We're taking our values that were given for x and we're plugging them in order to get our output or our y value. So when I plug in a 2 here, I get 2 times 2, which is 4, plus 1, so that is 5. Again, I want to follow that same pattern. 2 times the x, which in this case is 3, so 2 times 3 would give me 6, plus 1, which would give me 7. Now you may have started to see a pattern in this output slot or your y value slot, but be careful because not every time will you find that pattern. Here it's happening because we have x values that go in order, but if you don't have x values that go in order, it's going to not have a pattern down there in the y values. So let's plug in our last one. 4 times 2, or 2 times 4, they mean the same thing, is 8, plus 1, so that would give me 9. Okay, so we finished our first table. So again, if you're understanding this pretty well, you can pause the video here and fill in your next 2 tables, and then just restart the video so that you can check. Okay, so your second table has been filled in, so check your answers and see if you got them right. If you didn't, then just double check and make sure you substituted and multiplied correctly. Remember, 3x means 3 times your x value, and then you also want to add 3 to that. So again, 3 times 1 would be 3, plus 3 would be 6. 3 times 2 would be 6, plus 3 would give me the 9. 3 times 3 would be 6. Oh wait, did I do that wrong? Yes, I did. 3 times 3 would be 9, plus 3 would be 12. And then 4 times 3 is 12, plus 3 would give me 15. So moving forward, notice here that your x values do not follow any particular pattern. They don't go in order. You have 2, 5, 8, and 10. So make sure you're paying attention to what is coming out, or your output, when you plug these in. So 2 minus 2 would give me 0. 5 minus 2 would give me 3. 8 minus 2, which is my pattern here, would give me 6. And then 10 minus 2 would be 8. Okay, so far you've completed several input-output tables. You're doing great. Our last thing is to be able to look at a line and be able to tell what points it passes through in order to write this equation. And what we're going to want to do is record those in our input-output table. So what I'm going to do is come over here and I want to look at my graph. Now notice that the line runs through different spots, but what I want to do is find where it actually crosses two lines, where it intersects. So the first place I see that's really quite obvious is at the point 1, 3. Okay, so notice in my chart down here, there is a 0. So I probably need to figure out where it crosses the y-axis when it's at 0 on x. And as you can see, it passes through this middle part. And do you remember what the middle part is where the two axes cross over? It's called the origin. If you said origin, then awesome. You're really remembering stuff because this is from Unit 1. So where it crosses the x-axis at 0, it's also at 0 on my y-axis. So I want to fill in that 0 down here. 0. Okay. Then again, going back to my graph up here, the next place that I see it crosses over is at 2, 6. And then I think the last place I can tell it crosses over is at 3, 9. So we want to record those in our chart at the bottom where these dots cross over, or where we placed our points on this line to help us determine what the equation is. So at 1, so on my x-axis at 1, I can see that it crosses the y-axis at 3. On the x-axis at 2, I need to scroll up a little bit, I can see that it crosses the y-axis at 6. So I need to write that in my chart. Let's move the trash can. And then at 3 on my x-axis, when I scroll up, I can see that it crosses the y-axis at 9. So now that you've got your graph plotted out, you've got your chart filled in, we can actually write an equation, because remember, we want to see what's happening to x to make it into y. So let's look at this chart. So 0, 0, that doesn't help me very much. So I probably want to look at my next point, which is 1, 3. So the first thing you probably think is, well, 1 plus 2 is going to give me 3. But remember, if we follow that rule, it has to work for each one of our ordered pairs. So if I do 1 plus 2, that is 3. But is 2 plus 2 equal to 6? Because right now I'm saying that my equation is y equals x plus 2. That was my thought. But if I plug in this 2 here, is 2 plus 2 equal to 6? Well, that's not right. So we know that this is not the correct equation. So we want to try something else. So the next thing I think of is, well, maybe it's times 3. So maybe it's x times 3 is going to give me my y value. So remember, when we write that, we don't want to write x times 3. We write 3x, because that means 3 times your x value. So let's see if that works. 1 times 3, well, that would be 3. What about for 2 times 3? Well, yes, that is 6, so that works. And then we want to check it on this last one to make sure it still works. 3 times 3 would give me 9. That is true. So the only one I haven't checked it on is this first one. So you still want to check it on each value. So is 0 times 3 equal to 0? Well, yes it is. So if you have any questions, remember we said that our equation was y equals 3x, so let me record that here really quickly. If you have any questions, I have a discussion board open on It's Learning, so please submit your question. You have another sheet to do. You can use these notes to help you. If you need to rewatch the video, please feel free to. I hope you guys are having a great day, and I will see you tomorrow. Bye.